Hi again, this is Mrs. Ostrov, and we're going to be talking about multiplication. This is our part 3 of our video. You can catch part 1 and part 2 in the same playlist. Now this video is going to start off as a continuation of part 2, so be sure to catch part 2 if you haven't already. So in part 2 we spoke about the area model, and our example was 8 times 13. So if I have an array of 8 times 13, I can actually see the boxes. But in the area model, we don't see the boxes. It's basically just a blank rectangle. And the 8 represents 8 units on this side, and 13 represents 13 units on that side. And if I wanted to use the distributive property and split 13 into 10 and 3, which we spoke about why that we'll actually talk about why that's going to be an efficient way of splitting it up, then I would basically just draw a line to show that I have two different rectangles. And this rectangle is an 8 times 10 rectangle, while this one is an 8 times 3 rectangle. So 8 times 10 would be 80. So the area of this section is 80, this rectangle. And the area of this rectangle, and we'll put another 8 here just to make it really clear, would be 24. And then to get the full product of 8 times 13, I would add 80 plus 24, and that would give me 104. But now let's take it a step further. And let's take a two-digit number that's really not easy to multiply if we break it up in a different way. So 7 times 45, that's a really large number. And we're just going to be using the area model for this because at this point, making 45 boxes across would be completely inefficient. So now we're going to just think about this side as 7 and this side as 45. And even though the proportions are not really correct, we're just going to think about the representation, right? It's a model. So how would I split up the number 45 so that it's really easy to multiply? I mean, I could do 20 and 25, but 25 times 7 is kind of tricky. So what I would think about is taking this number and breaking it up into each place value. So the 4 is representative of 40, and the 5 is representative of 5 if we're thinking about place value. So I could break up that 45 into 40 and 5. And again, I would just draw that line to show that I'm separating my larger rectangle into two smaller rectangles. And then I'm going to try to find the area of 7 times 40, this rectangle over here, and the area of 7 times 5. And if I add them together, that'll give me my product for 7 times 45. So 7 times 40 is 280. And thinking back to part 1 actually of this series, we could think about 7 times 4 is 28, and then just dropping in that 0 there and making it 280. And that's a nice trick that's going to help us with multiplying these multiples of 10. And now 7 times 5, if I want to drop in that other 7 there to make it clear for myself, I could do that. 7 times 5 is 35, and if we add those two together, 280 plus 35 would give us 315. So that makes it really simple to take a more challenging problem for students at this point, 7 times 45, and break it up into bite-sized pieces that they can actually multiply. Let's try one more, 9 times 76. Now again, we're going to think about breaking up that 76 into the place values. So we have 70 and 6. We're going to drop that line to separate our two rectangles. And now if I want to do 9 times 70, I'm going to think about the basic fact in there, 9 times 7, which is 63, and then dropping in that 0, which would make it 630. And then 9 times 6, which would give me 54, and then if I add those two up, I'm going to get my product, which is 684. So try some on your own, pause the video, take out a pencil and paper, try out these 2, 3, 4 examples, just to give it a shot and have a sense of what your students are doing as they use the area model. And you'll find that it could be a lot of fun. We're actually going to take the area model now, and we're going to expand it into 3-digit numbers times a 1-digit number. So my example here is 6 times 251. So it's pretty pretty easy to transition from a 2-digit number to a 3-digit number if you're using the same understanding that we had from before. So if I take the value of each digit in the number and I expand it, so basically I'm taking the expanded form of 251, it makes it really easy to break up my number into friendlier numbers that I can multiply. So I would break the 251 into 200, 50, and 1. And I'm going to drop in 3 rectangles now because I have 3 separate rectangles that I'm going to try to find the products for and then add them up. And if I want to look at it as one long number sentence, we could do 6 times 200 plus 6 times 50 plus 6 times 1 because we have to add them all together. Add all the products of each rectangle together to get the area of the larger rectangle. So let's start by doing 6 times 200. 6 times 2 would be 12. Adding in those 2 zeros would be 1200. 6 times 5 is 30, and this could be a little tricky for students because there's a 0 in the 30, but we keep that 0 and we drop in this other 0, and that gives us 300. So we see the 30 in there plus that extra 0, and then 6 times 1 is 6. So now we have to add all these up, and we get 1,506. So a really simple extension from 2-digit numbers to 3-digit numbers. And this is going to relate directly to the next step, which is partial products, which if we're taking the same example, 6 times 251, and we take a look at the area model that we just spoke about, basically we're using the same idea of multiplying by each place value, just without really using that model, right? The model is a stepping stone for us to get into more abstraction. So this is the next level for students. So we would line it up vertically, so 251 times 6. And what we're basically going to do is take each place of the larger number, and instead of thinking about it as a 2, like you would when you're doing the algorithm, we're going to think about the value of that number. So we always start with the larger number when we're doing partial products, although you could start with a smaller number, but generally we start with the larger number. 2 in the number 251 is 200, so we would do 200 times 6 is 1,200, which would be this rectangle right here. Then we're going to look at that 5, and we're going to say that's 50. 50 times 6 is 300, which corresponds to this rectangle right here. And then we're going to look at the 1, and we're going to say 1 times 6 is 6, which is this rectangle right here. And then all we have to do is add those numbers up, and they're already lined up for us, so it makes it nice and simple. So it's exactly what we did with the area model, except now we're taking it a step further, and we're just doing it with the numbers itself. So let's take a look at a different example, and we're going to start by just doing the partial products with the numbers, and then we'll continue by looking at how that looks with the area model. So here we have 485 times 7. So again, we're going to start with that 4, and that 4 represents 400. 400 times 7. So I could think about 4 times 7 is 28, plus those 2 zeros is 2,800. Then I'm going to think about the value of that 8, which is 80 times 7. So 8 times 7 is 56. So with that 0 would be 560. And then I'm going to take the value of that 5, which is 5 times 7 is 35. If I add all those up, I get my product. There's 485 times 7. And again, if we take a look at what the area model would look like for that, it corresponds exactly. So here we have 7 times 400, and that larger rectangle is my first product, right? And it's called partial products because you're taking the product of each rectangle and then adding them up. The 560 corresponds to my second rectangle, 7 times 80. And that 35 corresponds to my third rectangle, 7 times 5. And that's all we're going to discuss for today. Thank you.